Hi, welcome back to again one more video on Arduino interface or sensor interface to audio. In the last video we have seen how to turn on a DC motor. So when switch is pushed, now we will see the second task where turn on red LED 1 if switch SW2 is slided to right position, and turn on green LED for 1.5 second. I don't know whether we're just making 1.5 second or not. So now the intention is to turn on a red LED if switch 2 is there in right position, and turn on green LED if the switch is there in left position. So this is the task now. So let us try to see how do we implement this using a switch. Now this is the circuit, whole circuit what we are looking at. So last time we just had a look at this, how does this push to on switch can be used to turn on the motor. Sorry for the disturbance. Now let us see. Now this is like a sliding switch. So now this is a toggle switch. I am representing that as a sliding switch. If this switch 2 is there in this position, then it will be giving 5 volts. The switch is there in this position, so then it will be 0 volt. So naturally, what you are trying to read from this particular pin 8 is whether it is logic high or low. It cannot be anything other than that, because this can slide to either VCC or ground. If it is slided to VCC, I should turn on a red LED, and if it is slided to ground or to the left position, it should be off. It will be, or one more LED should be on. So that's what the task is. So you can see, turn on red LED if switch SW is slided to right position, or turn on green LED for 1.5 second if switch is slided to left position. So let us try to see. Now we are using two LEDs, one is red, other is green. So this should be on whenever it is there slided to right. This green should be on for 1.5 second if it is slided to left position. So let us see the implementation of the same thing in TinkerCAD. Let me go here and then try to see this. This is my, of course it has got all the different interfaces. Now this is the switch what we are looking at. So this is sorry, sliding switch. This sliding switch has one common terminal, and it has got terminal 1, terminal 2. This is sorry, analogous to this. So this is common. This can be terminal 2, this can be terminal 1. So if you see here, now this is connected to VCC. Now let us treat this as terminal 2, and this is terminal 1 which is grounded. So let us treat this as terminal 1. So this is terminal 1, terminal 2, this is common. You can see common is going to pin number 8 as per the circuit diagram. Let us see where this is going to. Let me just give me 1 minute. Where is my TinkerCAD? It's here. Now this is, you can see it's going to, how do I make this to go off? I did not have to. I can see this is my output pin. It's going to pin number 8. See here, this is going to just trace this green line. So green line is going to this is common, going to pin number 8, exactly this connection. This connection is there, and this should read a digital value. So that is I should read a digital read from this pin number 8, and if it is slided to one position, it should be turning on red LED. If it is in the other position, it should be green LED. You can see I have two LEDs here. So one is red, other is green. You can see the output of these two. See here, this is pin number 7, pin number 4. So pin number 7 is going to red LED, and pin number 4 is going to green LED. And if you see the code here, and since these two are actually giving the output to this, so these two should be output pins, whereas pin number 8 should be defined as input pin. So since it is taking from switch 2, so let us see what the code is. You can see there is a switch 2, pin number 8 is assigned to switch SW2. You can see SW2 is defined as pin mode input, and we have these two LEDs, LED1, LED2. So those two are defined as, you can see this is red LED is 7, green LED is 4. So this is what is red LED is output and green LED is also output. If you just come to the code part of it, if you can see here, so this, if digital read or this switch position is in this right position, so you can see red LED will be on and the green LED will be off. Now you can see else, suppose if this is not high, so then red LED is low and green LED is on. So what I can do is I can just make the green LED on. You can give a delay of, so this is a delay of you can just give it as, because you are looking at 1.5 second, so you can just give this also. So now this is the code. Now actually what I'm trying to do is I'm trying to read the digital value from switch 2, because it will be either, it will not be anything other than 0 or 5 volts. So it is a digital read, and I have to write this LED to glow as either high or low. So I'm just doing the same thing. So this is again digital write, red LED high, green LED low. When it is high, when it is low, it is the other way. So let me see the simulation. Now you can see, now since it is in this position, so this green LED is on. If I just put it to this condition, now you can see this is red LED is on. So now, so we can able to make one LED on or another LED off, or vice versa. So I can able to do so any one of them. You can see now this is on. So what we are trying to do is we are trying to read a digital value and then write a digital value onto the LED. So that's what we are doing. Let us see the next task. And of course I will leave it to you people how to make that 1.5 second on. So it's just very simple task. I want you people to explore, okay, how do I make, because in the code I have made it 1.5 here. So this is 1.5. You just make sure that this works as per your requirement. So just tweak what the thing is. So it's worth spending some time how to make this. Now it's not actually working here, it's not actually going off. Make sure that you do something to fix this problem. So it's worth spending some time. Okay, next let us see what is the next task is. The next task is turn on bulb 1 if PIR sensor detects any object. So because it's usually in the typical application, if someone moves in a particular area, assume that okay, if a person comes inside a corridor or if he walks on a corridor, that corridor light should turn on. So it should not be on all the time, even if there is no movement. So in order to save energy, you can able to use such type of applications where you can install PIRs in the corridors. If there is a person coming during night time, then only that corridor light will be on, otherwise it will be off. So something like that type of real-time application. So you are sensing the object position, object movement in a particular area using PIR, that is proximity IR sensor, and you are turning on a bulb. So let us see how do we do this. So the circuit for this is something like this. So this is the circuit what you have. This is my PIR sensor. It has got ground, VCC, and there is an output pin. So output pin is actually being read. The presence of an object will be sensed by a PIR sensor, and its output will be given as input to the Arduino. So this is pin number 6 is used as input, which reads the output of this PIR sensor. and once that is if an object is detected, or if there is a movement of object happens, it will give high, otherwise it will be low. So now I have a motor here. You can see this is a motor. So sorry, this is a bulb. So this, whenever there is a movement, this will become high. So now usually motors will be operate at a higher voltage. It can be either a high DC voltage motor, or it can be running on a AC. Of course, this is a bulb, so this can be a DC bulb or it can be AC bulb. So that's why I'm written plus minus or line neutral. When I say line neutral, it is like, okay, maybe 230 volt supply. So when you are having a bulb which operates at very high voltage or a very high voltage AC signal, then this Arduino cannot drive that. So I have to use a relay circuit. This is single pole double throw relay, so which has got a coil. So it will going to have two terminals. Maybe you can just, I'll show you that. And it will going to have three terminals, two for the coil, and there is a common terminal, there is a NC, there is a NO. So NC stands for under normal condition, that is whenever there is no current flowing through the coil, this common will be connected to this terminal. So that's why it is called as normally connected. When I say normally connected, this common is connected to this terminal, so that terminal is called as NC. And under normal condition, that is when there is no current flowing, so this terminal is open with common, so that's why it is called as NO, normally open. So this is what is NC, NO. Whenever current flows through this, whenever sufficient current flows through this, this will energize the coil. I will have this movement of common will be going from NC to NO. So this NO will be get connected to common upon current flowing through the coil. So during such case, you can see here I have connected negative here. The positive of this is connected to bulb, and then it is connected here. Under normal condition, as per this, so there is no closed path, so bulb will be off. Whenever current flows, this will be get connected to NO, so naturally there is a closed path, then the current flows to the bulb, and then this bulb glows. So now typically what we are trying to do is, we are trying to read a digital value inside the Arduino using digital read, and I want to write a digital value onto this relay to make this common to go to NO, so that it establishes the circuit, closed path will be established, so this bulb glows. If it is not detecting any object, then the voltage read is 0, you will be giving 0 volt here. Since it is 0 volt there, no current, it will be under normal condition, so circuit is open, the bulb will be off. So let us see this in TinkerCAD. So this is what I have. Okay, now what we are looking at is the bulb. Can you see this is a bulb? This is a bulb what I have. So this is the relay what I have now. So this is a relay. So relay has got so many, if you can carefully observe all these relay things. I actually said okay, let me just do it here. Let me just relate this relay with this whatever component you have. So let me just take out, okay, this I'll take it out. I was just trying to find out how do I just move it away. Now this is fine. Okay, let me just bring this also. Okay, come on. Okay, this is fine. So this is my PIR sensor. So this is the PIR sensor. If you can see, this is PIR sensor. You can see PIR sensor, so and so, and it can see there are three terminals for this. So in this particular connection, I have used for ground it is black wire, for VCC it is, for power means 5 volt. So we are using red wire, and the output is a different color so that we can differentiate. Okay, this is the output coming from PIR sensor, and it is going to pin number 6, which is defined as input port. You can see, is this going to pin number 6? Just click on this. Can you see this is going to pin number 6? So now this is an input pin which reads the output of PIR sensor. Fine. So this connection is established. So this is connected to VCC is that power pin is connected to 5 volts, ground is connected to ground, and the output pin is connected to pin number 6. And let us come to this relay. So in this relay, let us see this 1-to-1. Can you see there is a connection here? This is my coil, exactly this. So one end is grounded, the other end is connected to this pin number 5. See here, so we have just used the same color as it was the output of this. Can you see? This was my PIR output, and you can see pin number 5 is connected to relay. You can see this is pin number 5. See here, this is pin number 5. E is going to one end of the coil. Where is coil? If you carefully look at this, so this is one terminal, this is coil, this is this. This is actually common in this particular TinkerCAD. They are using 2 terminals for common, and so here in the representation we have only one common terminal. So let us use any one of them. So this is terminal, this is also a common terminal. Both are common terminals. So if you look at this diagram, it is very clear, and you can see this is one end of the coil, which is exactly this. This is one end of the coil, this is the other end of the coil, and you can see this is if you see here, this is my common is connected to this, so it's exactly this one. So this is actually normally closed and this is normally open. So we are not connecting any connection to this NC. That's why you can see this is not connected anywhere. This is connected to pin number 5. That's exactly this coil connection. Other end of the coil is this. You can see that is actually we are actually connecting. Let me just stop simulation. Let me show you that. Okay, this is that connection. So this is that ground connection, and you can see this is actually NO. This is NO. Can you see this is NO? It's actually going to the bulb. See here, this is going to bulb. So this is my NO connection. This is my NO connection. So just have a look at this. Come on. This is NO connection. This NO connection is going to bulb. This is exactly 1-to-1 as your circuit is. So NO connection is going to this. You can see other end of the bulb should go to positive or line of a, because I don't have a AC power supply in this TinkerCAD. So what do you mean by other end? Other end is other end of the bulb. Other end of the bulb is going to where? You can see since I'm using a DC power supply, I want to limit the current. I'm using a resistor and then connecting it to the negative of the power supply. So how about the positive of the power supply? So if you see here, positive of the power supply, or of course you can vice versa make this common is getting negative. So you can see now this is my common. So maybe you can suppose if you want to do as per that connection, what I can do is I can just simply delete this and then I can delete this also. What I can do is I can connect this to as per that I'll connect it to this. Since it is positive, I will make it red. Now I'll make this is my common. I can use this or I can use this. Let me use this and then make it to go to ground. So this is, let me ground it. This is exactly on the same lines as that of your circuit is. You can see now from the bulb it's going to plus. So from the bulb it's going to plus. From the common terminal, it's going to minus through a resistor. Why a resistor means because this is a DC power supply. I just want to limit the current. Okay, that's it. So what we have is a PIR. Its output is being let me just relate it to this. This is PIR. Its output is connected to pin number 6 here. So this is pin number 6, and pin number 5 is the output, which is connected to relay. One end of the relay, the other end is grounded, and then I have a common connection going to this, and NO is going to bulb. The other end of the bulb is going to the plus of the power supply. So this is exactly the connection. So this is very simple. So you may have to identify those NC, NO and coil. You can see these two are common terminals. This is coil and this is NO, this is NC. No need to remember if you have a look at this carefully. So this is naturally NC and this is one end of the coil. This is one common terminal, second common terminal, both are same. This is one end of the coil, this is NO. So let me run this. So what we are expecting here is if there is a detection over here. So what I'll do is, you can see now, so when there is a when there is a movement happens, you can see this is glowing. This is glowing. Of course, PIR sensor has got its own property that it will be giving output voltage for some time only. You can see whenever there is a deflection happens, this will glow, and of course this will go off. So PIR sensor, if you can just observe how does the PIR output will look like. So this is how a PIR sensor will respond. So this is how a PIR sensor. Suppose there is a detection, there is no detection, it will be 0. If there is a detection, it will go to high and it will remain for a predefined time and it will again come back. So this is the property. So that's why when you this is actually 0 here, when it is what goes to this will become, so this is low, this is high. So here the bulb will be off, here it will be on for a certain duration. If there is no movement, it will be off for as long as there is a movement happens in the PIR sensor vicinity. Let me go over here. See now, even though there is a object present, since there is no movement, it is off. So there should be a movement should happen so that the pulse will come. You can see, suppose if I slightly make a change, it will have a movement, it will detect the movement and then it will make that. You can see now. So this is now, once as long as it is red, it is on. Okay, afterwards it just goes. If it is now here, it will be off for all the time. So suppose if something is happening here, if there is a movement happening here, it's off. The moment it comes to this region, now you can see it has detected. But here, if object is present here, if there is no movement, it's again off. So if this has to turn on means, so you need to have a movement. So there should be a movement happening here, so then only that will want to glow. Okay, fine. I hope you are getting this concept. Okay, whatever that we thought of. So it should be on whenever a PIR detects any object in that vicinity. Okay, we'll see another task in the next video.